This is the video for do a gray code search. Here on the upper left is the routine for doing the gray code search. Below it is some of the data from the gray data file, starting at offset 20 and only going to offset 85. Over on the upper right here is the offsets file, and it has its data from offset 0 to offset 75. Below that is the routine that uses the best list data to make the gray quantities. Well, first we're going to do the gray code search. It first sets control register NS to 10. That's because this instruction down here, add list, needs to know how many values are in the list. In this case, 10. Then it sets test values to tray income. This particular example could possibly have a solution before the test is made. That solution had this income called tray income. So it starts test values out with that income already. Also associated with that income is a binary value saying which bits are in that solution that had the tray income. And it puts that binary value at test values plus 1. It also is going to need to know this solution's quantity of each part that is left. In other words, if this solution uses some of the parts, we would just want to know how many of each part is left. So that's in this list called tray left. We're going to move those 8 values, because there's 8 parts, to test values plus 2. So now we have 10 values in test values. Then for I equals 1 to next I trials, we're going to go around this routine here, this loop, to find which is the best value given this beginning solution. Well, first it's going to set J to offset at I. Well, over here are the values, and the first I it has is 1, so it's really pointing to this 20. So the first time it goes through here, it's going to get that 20. Well, the next line says, do the add of the gray data at that offset of 20 and add it to the test values we have now to give me the new test values. Then the next line says, if that's less than or equal to the best income I already have, go down here to CE. That's down here. In other words, it's no better than a solution we already have, so we don't need it. Well, if it says, well, it is better, we're going to say for K of 0, down here to K of 7. Well, if it goes from 0 to 7, that means it's going around 8 times. It says, is that value at test values plus 2K, okay, that starts at offset 2. These are the values of how much each part is left. Well, if that's less than 0, go to CE, go down here. And it does that test for every one of the 8 parts. You can't use more parts than there were. And if you try to do that, this is going to go less than 0, and it's not really a good solution. However, if it passed that test, and it is a good solution, then we say our best income is that test value. And we also move the 10 values from test value at this particular time to best list. For one thing, we need to know what the binary value was when this best test was made. There's a binary value for every one of the solutions. Alright, once this is done, it goes down here to figure out if that test value has the solution value in it, we need to know what that is. What are the quantities? So it comes down here. First, it sets all 8 of the gray quantities to 0. Then it sets B to that value at best list plus 1. That's the binary value for the solution. Then it sets N to the bit count and subtracts 1 from it. Well, it wants to go around this routine here for the bit count, but it starts at offset 0, at value 0, so therefore it will go around here for the bit count time. Then next it sets A equal to the value of B, and then mods A with 2. So it's going to be a 0 or 1. So the first binary value that it gets, the lowest one in the number, is in A as a 0 or a 1. In our case, the first time it will be is this particular one at offset 20 in the solution or not in the solution. If it's a 1, it's in the solution and will continue on down. If it's not, it'll go down here to DE. But before it even does that, it divides B by 2. So then B is going to shift 1 to the right, and then the lowest bit is going to be for the second one, and that one's at offset 40. And over here is where offset 40 is. Well, once it says, well, this one was a 1, it sets J equal to the bit's item number. And then it says it's going to add the factor for that item number into the gray quantity. Remember, if this is the one just at offset 20 for the first item, well, that factor is a 1. If it's the second one, the factor is a 2. The third one, it's a 4. And the fourth one, it's an 8. So this is taking the value of the bits, and if the bit is on, then it says this is the factor for it and adds that to the quantity. And then it goes around here for every one of the bits. Now let's take a look up here at the offsets file. The first one we know it looked at was 20. That means bring the first bit into the solution. The next one was 40. That means bring the second bit into the solution, which we know in fact is still the first item, but at 2, a factor of 2. Then the next one, 1020, is taking it out of the solution, that first one. Then the next one, 60, is put the third one into the solution. Then it says put the first one back in the solution. Then it says take the second one out of the solution. This is the way the gray code search works. It either puts one item into the solution or here takes one item out of the solution. That makes it run very quickly because it's only doing one thing each time. Remember over here when we were going around, it did this add L just one time. And it was either putting an item, well, a bit, into the solution or taking that bit out of the solution. So this is really just showing you what the gray code looks like. It's putting one in or taking one out. All right, this is the end of the video on Do a Gray Code Search.